Question number 25, worksheet connected particles. The diagram shows a particle of mass 5 kg on a rough horizontal table. Okay. 5 kg means a downward weight of 50 newtons. And two light inextensible string attached to it passing over a smooth pulley fixed at the edges of the table. The particles of mass 4 kg and 6 kg hang freely at the end of the strings. Okay, so this weight is going to be 60 Newton. This weight is going to be 40 Newtons. There's going to be tension 1 here. This would be T2 because these strings are two separate strings. So they'll have different tensions. Okay, in this direction, we'll have T2. In this direction, we'll have T1. Okay, and since this side is heavier, this will go down, this will go up. The 5 kg particle will move in this direction, hence friction mu r will be in this direction, and r is the normal contact force, which is in this direction. Okay, the system is in limiting equilibrium. Show that the coefficient of friction between 5 kg particle and the table is 0.4. Okay, so at the 4 kg particles, we know T1 is equals to 40. At the 6 kg particle, we know T2 is equals to 60. And at the 5 kg particle, the one in the middle, we know the T2 is equals to T1 plus mu r. T2 is 60 is equals to T1 is 40 plus mu r is opposite to this. They're equal. So this would be 50. So mu is equals to 20 by 50, which is 2 by 5 or 0.4. So shown that mu comes out to be 0.4. The 6 kg particle is now replaced by a particle of mass 8 kg. So we have 8 here now and 80 newtons downward force. Find the acceleration of the 4 kg particle and the tension in the string. Okay, so for part B, the system will now move. So the 8 kg particle will have forward force minus backward force is equals to MA. That means T2 is equals to 80 minus 8A. Next, at the 4 kg particle, in fact, at the 5 kg particle, we'll write T2 minus T1 minus mu r is equals to MA. M is 5 and A is just A. So we get T2 is 80 minus 8A minus T1 minus mu is 0.4 and R is 50 is equals to 5A. Okay, so we have 13A here and we have minus T1 here and 80 minus 0.4 into 550. So 60 minus 13A is equals to T1. Okay, now let's look at the 4 kg particle. So the equation is going to be T1 minus 40 is equals to MA. So T1 is equals to 40 plus A. Now we're going to equate these two equations, get the value of A, then get T1 and T2. So we have 60 minus 13A is equals to 40 plus A. We have 14A and 20. So we have 20 over 14 as A, which is just 10 by 7. Okay, sorry, this was supposed to be 4A. This is 4A that I've missed, and there's 4A. So we have 17 here, and A comes out to be 20 by 17 meters per second squared. Okay, once we have A, we can find T1 and T2 from this, and where's T2? This. Okay, this will give us 44.7 newtons and 70.6 newtons. Okay. Next part says, in the subsequent motion, 8 kg particle hits the ground and does not rebound. Find the time that elapses after the 8 kg particle hits the ground before the other two particles come to instantaneous rest. You may assume this occurs before either particle reaches the pulley. Okay. Now, when the 8 kg particle hits the floor here, this particle would be somewhere over here and the string will slack. When the string will slack, it will pull this particle further towards the right. And we need to find the time after this particle is released. Till after this particle, yeah, it reaches the ground or hits the ground and till this particle comes to instantaneous rest. So we basically need the time frame during this period. Okay. So for this period, we know that U is 0 because initially the particles, no, not 0, I'm sorry. V would be 0 for this period because the final speed will be 0. Then we know that we can find U. How do we find U? We can find the U here or the V here. What's going to be V here? The U here is 0 and the A here is, we calculated it 20 by 17 and the distance covered S is 0.5. Says so in the question. Okay, so now use these. V is 0. Sorry, U is 0. V is what we have to find. A is 20 by 7. S is 0.5. So we can use V squared equals U squared plus 2AS. So square root 0 square plus 2. A is 20 by 17. And S is 0.5. This gives V equals 1.0846 meters per second. Okay, so we now know that this speed here, as this particle hits the ground, this particle will have the same speed, which will now be counted as U, which would be 1.08465. Okay, so now we know that U is 1.08465. Eventually, the particle comes to rest, so V is 0. We need the acceleration, and we can find the time. Okay, now the acceleration will change because this string towards the right has no tension in it. T1 is 0. Sorry, T2 is 0. So we're going to reuse the formula on the 5 kg particle, but now T2 is 0. So let's rewrite this and get acceleration again. T2 is now 0, forward force is 0, minus T1 minus mu r is equals to ma. Okay, now find T1. T1, just a second. For T1, we're going to form an equation on the 4 kg particle again. So forward force minus backward force is equals to ma. So T1 is equals to 4a plus 40. Okay, substitute it here. So minus 4a plus 40 minus mu came out to be 0.4. Yes. R came out, R was 50 is equals to 5a. Okay. We solve this and get the value of a. Okay, this is supposed to be minus as well because it's minus T1. And T1 is this, so the sign of 40 is also supposed to be. Okay, now use this and get the value of A. We get 9A here, and we get minus 60 here, and we get A is equals to minus 20 over 3. Okay, so this A is minus 20 over 3. Now all that is left is to find T. We will use V is equals to U plus AT. V equals U plus AT. V is 0, U is 1.08465, plus A is minus 20 over 3, times T is what we have to find. Solve this and get P equals 0.163 seconds.